We want to do a quick example of designing an 8-to-1 mux using smaller instances of 2-to-1s and 4-to-1s. A couple ways we could do this, but I'm going to illustrate one. And that'll also illustrate how we do, again, our port mapping from global input outputs to local instances of objects. So a 8-to-1 mux has 8 data inputs, it has 1 output, and it has the 3 select lines that will choose one of the 8 inputs to be switched on to the output. The way I'm going to design this mux 8-to-1 is have a 2-to-1 mux in the back to select between 2 4-to-1 muxes that'll be in the front. As we've talked about in class, there is always one mux in the back that selects between the muxes that would be in the front. So this mux right here, his data input, let's go ahead and put that wire in there, is going to receive one of 4 of the global inputs that will be tied in over there. This is the most significant bit of the mux. That's the D1 input. So when this input gets selected, I will be receiving one of 4 of this mux right here. So since he's the most significant D1 input of this mux, these 4 inputs should be mapped to my most significant data inputs of the globals. He's the least significant input to the mux. As we've talked about, kind of carving the truth table in two, this would be the lower half of the truth table. That's how we're going to be mapping it. So let's go ahead and draw our buses for the data input and for the select input. Got to give them the names. Right here, select 2 through 0, that's good enough. And then I'll change the name for, call it DN 7:0. Takes care of 8 inputs. Just add the port map IO markers while we're at it. Okay, I'm going to zoom in here to do the busing. So we need wires to tap back from my local instance name D0 to the bus. Automatically add a bus tap. Don't forget to have that checked if it's not. And just pull straight back to your input bus. Go ahead and do that for all 8. Then we have to go and rename these wires with the global names. Xilinx gives them just some kind of local names, or temporary names rather, XL, XN, whatever. So port mapping is actually to change those names to our correct global names. Almost there. Now I'm going to have to do the same thing with the select inputs. The select inputs are going to be connected to this bus. I didn't reach it. There we go. So all of these local names, I've got 2 S0s on the back end muxes. I've got another S0 on this mux right here. So port mapping is mapping these local instance names to the appropriate global instance names. Now the enables on the multiplexers we're going to tie to VCC so that those 2 front end muxes will always be enabled. So I'll do that with VCC right here, pulled up, pull the wire down to that enable and this enable. So these 2 muxes are always enabled. Just so happened that this mux on the back didn't have the enable. And I need an IO marker on my final mux. There we go. I'll call that, just give them a name, mux out or something like that. Mux out. Well, if I could spell it right, that might be better. Okay, right now if I do a check, I'm going to have lots of errors. A lot of warnings, 13 errors and 15 warnings. And the reason that is because this is connected to a bus, but it's still got a temporary name, XLXN 8. This is connected to a bus, so it wants to have a name of SEL either 0, 1, or 2. So that's where all my errors are. So, as we've talked about, port mapping, we have to name our signals. So, Xilinx has a nice little feature when you're doing buses, that it will automatically increment the name after we use it. So you can keep the name the same or increase the name once it's used. So I'll start with D0, which should be this least significant mux, his least significant input. So I've now changed his name to D0, and the name has been incremented over here to DN1, so I don't have to retype it in. This should be the DN1 input, DN2, 3, 4, 5, 6, and 7. Pretty cool the first time you use it that you don't have to keep typing in those names. Now, as we've talked about in class, the multiplexer that's in the back will always use the most significant bits of the selects to choose between the smaller muxes or the muxes that are on the left-hand side. So the most significant bit of our select is SEL2. So this name has to be SEL2. SEL bracket 2. Now if I say decrease the name, the next time I use that name it'll be SEL1. So here we go, global port mapping from SEL2 to local instance S0. Most significant bit of the select always controls the back end mux. What about S1? S1 is going to go to the S1 of both muxes. S0 will go to the S0 of both muxes. Now I have to reset the name, or since it's right now select 0, I'll say increase the name. This S0 gets select 0, and it increased to select 1, select 1. I am finished. This is an 8-to-1 mux that I am very confident will work. Have it redrawn. Global mapping. Global input names spread out to the local instance names. Global input name, select 2, select 1, select 0, going to the appropriate selects on the back end. So that's a quick example of port mapping.